Good morning, everyone. Before the spring break, we went over this question number 27. And in the step of completing a square, I made a mistake. Okay, that was negative 16 plus 5. It should be negative 11 instead of negative 9. I put a negative 9 in the lecture. That was a mistake. So for that reason, I made a sequence of corrections for that entire question, which is sent to your inbox message and send it to your pronto message. So hope you'll get it. Okay, so that was about the correction. Welcome back. And we have been doing quadratic. And we are going to do some more questions in 32A. And hopefully this will recap and we need to move forward. Now we need to move forward. Do you guys have any questions? Oops. Sorry about that. I'm going to make some adjustment. Do you have any questions? No questions? Okay. We did quite a lot of quadratic, and I think it's about time to change the topics. And we have done 32A. On 32A, we didn't quite finish. Okay, we didn't do enough about the quotient situation, And so now we're gonna come back to alpha 32A. Alpha 32A, okay? And I think I give you the homework up to 1, 2, 3, 4, 5, 6, and 10, 11, 12. 10, 11, okay? And today, do you have any questions about that? No? Okay. So let's look at these 4 questions we're going to work with. Okay, we're going to work on these together. Okay, 7, 8, 9, 12. These are the questions that we will be working on together. We talk about how to look at these questions, right? How the principles are being used. So for example, I think we did number 7. Okay, so I want to recap on this question. So we see this as a, so let me make the fonts just a little bit larger so you can see the minus sign here. So there's an x minus 3, okay? So we certainly can still use the same approach that we did the other functions. For example, we can use the same idea we work with quadratic, okay? But it seemed to be a little bit easier, so we just view this. Okay, we just view this as a quotient of 2 unknown numbers. Okay, so we view this as A divided by B, and we want it to be positive or 0. So this is an if statement, right? If the quotient of 2 numbers is greater than or equal to 0, and then we're trying to identify the value of x. Okay, so we want to identify or find all possible values of x. And the idea is the same. The idea is that, you know, we just have to check the sign. We just check the sign, okay? So when A is positive, B is positive, A divided by B is positive. When A is 0, B is not 0, A divided by B is 0, right? If A is negative, B is negative. Negative divided by negative is positive. When A is 0, B is not 0, then this quotient will be positive, will be 0, right? So we understand that principle, right? So principle number 6, right? Principle number 6 was really the guiding principle that we use. So solution, so let's recall. Okay, I think we did this one, didn't we? Did we do this one? Okay, there's a message on chat. Let's see who's saying what. No question, no question. Okay, do you still remember how we did this one? If we did this one, I thought we did this one, right? And we will look at the sign of x plus 1, right? And the sign of x plus 1, it changes sign at a -1. And x plus 1 is negative when we pick any number, plug in, and that's going to be negative. And at a -1, it's going to be 0, right? It's 0. And after -1, when we plug in any number larger than -1, the sign of x plus 1 is positive. And then we observe the sign of x minus 3. X minus 3 changes sign at 3. At 3. And after 3, right? When we pick any number, plug in x minus 3, it's going to be negative. If we pick any number less than 3, we plug in x minus 3, it's going to be negative. At 3, it's 0. And we pick any number larger than 3, we plug in x minus 3, we're going to get positive. And then, so you can see this method in idea using principles is really similar to what we have done earlier with a factored form of quadratic. Okay, so the place changing sign would be -1, +3, and these are the 3 intervals. So when we look at the sign of the quotient, when we look at the sign of this quotient, right? And then we will, let me just look at the -1, right? When we pick a number less than -1, we are doing a negative number. We're doing a negative number divided by a negative number, right? So denominator is negative, numerator is negative. Negative divided by negative is a positive. At a -1, when -1 is plugged in, we get a 0 denominator. Okay, so this is undefined. So we put an infinity sign there. We put an infinity sign there. And if we pick a number between -1 and 3, then we're taking a negative number divided by a positive number. Negative divided by positive is going to be negative. At 3, right? Numerator is 0, denominator is not 0. In this case, the quotient is 0. And after 3, x minus 3 over x plus 1 is a positive divide by positive. So that's another line of, separation, right? Let me just redraw this line. It's going to be here, right? So it's about here. Okay, so when we plug in a number larger than 3, we're going to get a positive divide by positive. Positive divide by positive, we're going to have a positive. Okay, so this is the sign of x minus 3 over x plus 1. So we can see that by applying principle number 6, applying principle number 6, we want the quotient to be positive or 0, right? If the principle is positive or 0. So when is the principle, when is the quotient positive or 0? Less than -3, at 3, and larger than 3. So the solution would be x is less than -1, cannot include -1, because at -1, it's infinity. You get a 0 denominator. We cannot allow that. Or x is larger than or equal to 3, because it can be 0. Okay, the quotient can be 0, so greater than or equal to 0. So that's the solution. That is the solution. Are you guys with me? Does everybody follow me? All right. So if you understand this process, if we understand this process, can you try number 8 for me? Please try number 8. Everybody, so please try number 8. Okay, so I want you guys to go through the process. Okay, go through the process. Let me see if I can make the screen so you can see the whole thing. This thing is so weird. Okay, hope this is better. Anyway, so you guys, please try number 8. If you understand what we're doing here. Okay, I'm just trying to make some more space for. It doesn't. Okay, we can do it. There, so we have more space. So are you guys trying number 8? So please do, try number 8. I did the same. We're trying to get familiar with this method. Okay, we're trying to get familiar with this method. Okay. Then you say, can we do the graph? Of course we can do the graph. Okay, of course we can do the graph. But we're gonna do it later. So let's get familiar with this particular method. Number 8. We wish to have a quotient x plus 3 over x minus 2 is less than 0. We want a negative quotient, right? So the if statement goes, if, right, that quotient is a negative, right? And still the same task. Identify or find all possible values. Right. So once again, principle number 6. Principle number 6. Okay, let me know when you finish. Got it? So the idea is very similar, actually. Just keep doing what you're doing. Okay, so we have x plus 2 here. I'm just stealing the work we did earlier. Okay. So I can quickly produce the answer. But the answer here, oh, wait. I made some mistake. Don't worry. Don't ignore what I did. Okay, just keep doing what you're doing. Okay. My bad. Plus 3 x minus 2 plus 3 minus 2 minus 3 positive 2. Ah, I think this should do it. Did I make any mistakes? You have to check your work, right? Even though just a change of numbers, then you see the sign of x plus 3 changes sign at a negative 3. At a negative 3, x plus 3 is 0. When we pick a number smaller than negative 3 and plug in, say we pick a negative 4, we plug in here, we get to have a negative number. In fact, you pick any number smaller than negative 3, you plug in, you're going to have a negative number. So that's what the negative sign means. Any questions? At negative 3, x equals to negative 3, x plus 3 is 0. When we pick any number larger than negative 3, say 2, plug in x plus 2, x plus 3, that's going to be 2 plus 3, that's 5. 5 is positive. So any number you pick larger than negative 3, plugging in x plus 3, you're going to get a positive number. So that's what this chart means. Okay, just in case. Okay, just make sure everybody is with me. And then we look at sign of x minus 2. And the sign changes at 2. And we plug in any number smaller than 2, we're going to have a negative sign, negative number. So then you say, why do you care about the sign? Of course, because we're dealing with sign. We're dealing with a question that sign is the center of attention, okay? And we want the sign to be negative, right? So we read this question, we know the sign is at the heart. So when we pick 2 for x minus 2, we're going to get 0, but it's a 0 denominator, right? So we need to be careful. And for larger than 2, we plug in x minus 2 is going to be positive. And then we observe the quotient. So once again, the same drill. For -3, and when we plug in any number less than -3, we're doing a negative divide by negative. That's going to be a positive. When we plug in -3 in this expression, we're going to get 0 as the numerator, and denominator is -5. 0 divided by -5 is 0. I made a mistake here. Okay, so it's a 0. Got it? So that's slightly different. On this one, between -3 and 2, if we plug in the number, we're doing a positive divide by negative. That's going to be negative. But if we plug in 2, and this is going to be infinity, undefined. Okay, undefined. And for all the numbers larger than 2, the quotient is going to be a positive divided by a positive. So that's going to be a positive quotient. So by this time, we have identified what number will cause the quotient to be negative. So when x is less than -3, the quotient is going to be positive. That's not what we want, right? That's not what we want. That's not what we want. If x is larger than 2, the quotient is going to be greater than 0. And what we want is the part that the quotient is negative. So when is the quotient negative? The quotient is negative. Well, we cannot include 0 because we want the quotient to be negative. So -3 is not. So the solution would be all the numbers larger than -3 and smaller than 2. So that's the solution. That's the solution. Did you guys get the same answer? Did you guys get the same answer? Do you think you get this method? Do you anybody want to propose any different methods? Anybody want to propose any different methods? Any idea of different methods? Anybody has done it differently? Some of you may find, oh, these steps are pretty tedious, right? Can you do a different method? Anybody has a different method you want to propose? Hello, let's see who's here. Brianna, do you have a different method to propose? Brianna, do you have any different methods to propose? What have you learned? Okay, thank you. I got your message. Francisco, do you have a different idea to approach this question? Because I have been giving you different methods, right? Francisco, do you have a different method to propose? No? Marcelo, do you have any different method to propose? Have you learned a different methods before? Okay. So Fatra, Do you have a different method to propose? So Fatra, are you there? Alan? Alan, are you there, Alan? Do you have a different way to approach to propose here? Okay, you guys have no other method to propose. Could I propose a method? What do you think? May I propose another method? Okay, say for number 7. So here's what I'm going to propose. Okay, greater than equals to 0. Okay, this is the if statement. So if the quotient is greater than equal to 0, so what I'm going to do is I'm going to multiply x plus 1 on both sides. And as a consequence, I'm getting x minus 3 larger than or equal to 0. And I will get x is greater than or equals to 3. The solution is slightly different from what we got there, right? We got this part. What do you think of this method? Isn't this easier? Isn't this method easier? Yes? I got a 1 yes. Does everybody think so? It's easier, but is it right? Is it right? You like it, huh? You like it easier, don't you? The question is it right? Is it right? We like it easier. Yeah? But the question is, has to be right. But is it right? In fact, this is one of those popular methods we often see because you find it easier. A lot of other people find it easier. Okay. There are a lot of other people in the world, they also find this method easier. So they use it. Is it right? Anybody want to take on that question? Is it right? Is it right? No comments? No comments? How do you determine is right or wrong? How do you determine it's right or wrong? Right, you can see obviously we get it, the answer we get here, obviously is different from the answer we got earlier, right? The answer we got earlier has x greater than equals to 3, or or x less than equals to -1. Obviously, this method will cost us to miss some method. We didn't get all the solutions, right? So you guys don't want to comment if this method is right or wrong. This method is popular, very popular, but it is completely wrong. Which step is it wrong? Okay, it's a popular method. It's a terribly wrong method. It's a horribly terrible method. What is wrong? You can see the place I marked. That step is wrong. The answer is easier. So this method is not right. It is completely wrong. Which step is it wrong? This is the step that is wrong. Okay, so don't use it. Yes, it is easier, but it is completely wrong. So are you going to use it? Please don't. Please don't. What is wrong? Right? So now I'm going to explain to you why. Why this step is wrong? Why couldn't we multiply both sides by x plus 1? Okay, so what does this mean? Now let's look at something more general, right? So from these conclusions, from these steps, we focus on the first step. We're going to focus on the first step, right? What do the first two steps imply? What does it imply? It implies that if, okay, if A is larger than or equals to B, then we multiply x plus 1 on both sides. So A times C is going to be greater than or equals to B times C. Do you agree with that? If we acknowledge these two steps are correct, you're acknowledging that then okay, so let's just look at these two statements. If A is larger than or equal to B, okay, let me just use greater than, okay? Let's just make it simple, just to keep it simple. If A is larger than B, okay, then A times C is larger than B times C. I want you to look at those mathematical principles. So is this right? Is it true? We're making a general statement. Is this true? Is this true? Everybody, I want you to put on your thinking cap. Basic logic. Basic logic. If one number is larger than the other, and you multiply the same number on both sides, A times C is still larger than B times C. Is that true? No answer? Are you guys there? The answer is no, that's not true. This is the fundamental, that is not true, right? See, how we derive this. So if this is true, that implies that is true. The question is that true? Are you guys thinking with me? The answer is no. And then you look at those principles, and then you say, oh, C should be not equal to 0. Did you notice that? C should not be 0. Would that be true? That is still not true. Okay, are you looking at principle number 4? Are you looking at principle number 4? Yes? Everybody, are you looking at principle number 4 on the first page of the note? It should be on your flashcard. Right? What is principle number 4? If A the same as B, then A times C is equals to B times C, provided C is not 0. Okay? This is true. Right? We have talked about this, didn't we? Did we talk about this before? We did. Now the sign is changed from equal to larger. Is that still true? The answer is false. Okay. Are you screaming? Why? This is true. That is false. What is wrong? What is wrong? Why? This is false. Why? Okay. Take an example. Okay, take an example. Look at the number line. Okay. On the number line, suppose this is 0. This is 0, right? We have a number which is 2 here and 3 there, right? 2 is here, 3 is there. Okay. Could I say 3 is larger than 2? Yeah? Is that right? 3 is larger than 2. But if I multiply both sides of 3 and 2 by -1, is that still true? -1 times 3 is -3. -1 times 2 is -2. Is this still true? That's not true anymore, right? This is a -2. And that is a -3. Is it still true? No. -2 is larger than -3. Ah, so what do you see? If I multiply 3 greater than 2 by a positive number on both sides, so if I multiply 2 on both sides, 6 is larger than 4, that's still true. But if I multiply by a negative number, the direction of inequality sign has to be reversed. Does everybody follow me? So this rule is not true. So if this rule is not true, can you use it? Of course not. course not. You follow me? So how do we make amends? How do we make amends? Right? How do we make amends? Here's how. Okay. If A is larger than B, if A is large, if C is positive, that will still be true. What if C is negative? And this has to be switched. That will be true. Did you write it down? Do you guys follow me? Is that clear? Is this clear? So we have this is true. This is false. And this is true. If we multiply by positive, it will still be true. But if we multiply by negative, so simply not equal to 0 is not sufficient. You have to know the sign you're dealing with. Okay. So this is the reason. This is the reason. Okay, or I can write it. You see, this is 2 less than 3. Well, you can write it any way you want, really. Okay. 2 is less than 3. Negative 2 is larger than negative 3. When you put a negative sign in front of it, you switch the direction. Don't you? Do you see that? Okay. So for that reason, I want you guys to write it down. Okay. And be convinced. I don't want you to have to memorize it. Okay. The simple reason is on the number line. The simple reason is on the number line. When you multiply the 2 numbers by a negative number, and then the direction is swapped, is reversed. You guys follow me? So this is false, and that's why you cannot do this. Okay, so this is the step. This is the step that is completely wrong. Completely wrong. Completely wrong. Okay? Because you don't know the sign. The sign of x plus 1 is unknown. Is unknown. We don't know is it positive or negative. If it's a positive, we don't switch. If it's a negative, we need to switch. So do we switch? We don't switch. Do you follow me? Can you write down the answer? Do you follow me? So yes, this method is easier, but it's a terrible mistake. Okay. If you still want to use this method, you will have to separate. You have to deal with 2 cases. You have to deal with 2 cases. You have to deal with 2 cases. Do you follow me? And I'm not going to talk about that 2 cases method because I don't want to make it more complicated for you. I want you to use this method. I want you to use the method we just talked about. Do you follow me? Does everybody follow me? You know why it's wrong, right? You know why it's wrong. Why didn't I use the easier method? Because that method is wrong. How common is this mistake? Let me tell you how common it is. A couple of semesters ago, I was hospitalized for a medical condition. So I had a substitute in my classes to teach pre-calculus. I had this substitute teacher, and he taught my class, and he taught this method. Of course, he used the notes. It was a pre-calculus class. He used the notes, and he was just going through the questions and work with my student. And I came back the following week, and I found this easier method was taught to my student. How should I be reacting? I was horrified. I was horrified. Okay, so even some of the teachers may not realize they have done the wrong thing. They have done the wrong thing. Do you guys follow me? So I have to correct everything. I have to make all the corrections and explain the details, explain why. Did I ever have an opportunity to correct that with that teacher? No, I didn't. I didn't get to see him again. Okay, so you might encounter someone. So we are at the teachers, we're on the podium, so-called podium. We're in the classroom, we're in the front. And if I knew if I had the opportunity to point to that teacher, and he would probably immediately realize his mistake. But I didn't have that opportunity, not yet. So those teachers, they're math teachers. Just like me, I made mistake. Remember at the beginning of the class, I told you I made a mistake. Negative 16 plus 9, I'm sorry, plus 6 is not a negative 9. I made a mistake. Anybody could have made a mistake. But you have to be critical about what you learn. You have to be critical about what you learn, because here's a because. If you learn a wrong method, you use that wrong method, guess what? Somewhere down the road, okay, because not all of us are going to make mistakes, right? Eventually, those ultimate solution will be examined and re-examined over and over again. So all the mistakes will be filtered out. If you still use those wrong methods and to produce the wrong results or incomplete results, you will still have to bear the consequence. So you need to be critical and you need to understand what you're doing. Do you follow me? Then you say, oh, it's unfair. My teacher told me that way. I'm sorry. It's not going to work that way. Okay. So 2 years down the road, you are at UC Berkeley and you do this wrong method. That UC Berkeley professor, hopefully he got this right. And you do this method, you do the way that was taught incorrectly. Guess who's going to lose the points? You got it? They're not going to listen to your argument, because in mathematics, right is right, wrong is wrong. We cannot make a right wrong, and we cannot make a wrong right, no matter who says it. Ultimately, the correct answer will prevail. Do you follow me? And you can already see that in these two methods, this method, I spent so much time talking about this method because this is a terrible mistake. This is a prevalent mistake. This mistake is like omnipresent. I have to correct this mistake every semester. Some of our students learn it from somewhere, right? If you tell me I learned this method from my, from Dr. John Doe when I was in high school, I'm sorry, when you come to my class and I saw this mistake, I still give you 0. I'm sorry, I cannot just say, oh, because you learned from Dr. John Doe, therefore I need to give you the points. No, you're gonna get 0. All right, do you follow me? So this is why it's so important that we understand the why. We understand the why. Okay, that's why I explained to you the why. Okay, so be critical of your teacher. Okay, be critical of your teacher. All right, so this is the reason why. This is the reason why. Did you guys write it down? So you cannot use this method. You cannot use this method. Okay. I'm not going to talk about these 2 cases unless all of you really want to. Do all of you want me to talk about the cases method? Let's have a vote, right? So it's about time we take a break. I am open to talk to you about that method, but it's a little bit, I would say it's a little bit, maybe a little bit too much for you, but I also think I have confidence that you can get it. Do you want me to talk about the other methods? Nobody says anything? Oh, you're tired? I'm sorry, I can still not make the videos to show my nice haircut. It's just I think the video might have problems, or the Zoom has problems. Okay, so we're not going to talk about that method. Okay, we're not going to talk about this method for now because nobody said anything. In the future, if you want to, when you're ready, and I will talk about that method. So please don't use this method. Okay, please don't use this method. This method we learned here, of course, is not the only way. And then because I also promoted the graphic method, the graphing method. Okay, so I'm going to show you that this can be done using the graphing method. Okay, just to show you the idea. But the graphing itself is not easy if you graph it by hand. But if you use a calculator, I want you to see that if you have a calculator, then this will be a little bit easier because you will view this as a function. You view this as a function. Remember the function idea, guys? Remember the idea of function, right? This is the function. With the same idea, it's the same idea. And you have input. And you have output, right? And the output, of course, is a whole thing. It's a whole thing, right? And of course, we also are aware of the domain, right? So what is the domain? Domain is x cannot be equals to -1 because we don't want that denominator equal to 0. With that consideration, when you do the graph, right? So I'm going to graph, suppose I'm using this, because we didn't talk about how to graph this kind of function yet. But in case you're using the calculator, right? You know how to use the calculator, and you have a beautiful, expensive graphing calculator. Sure, you can use it. Okay, I'm not against technology. Okay, so then you see this picture, then you say, oh my God, how am I going to find the solution? You can find the solution the same way as we did with quadratic. Okay, the same way as we did with quadratic. Okay, so let me just make a little bit of adjustment so you can see the picture a little bit better. Okay, -4. So this is 5. That's good. So this is making -5, +5. Okay. That's not too cool, actually. I'm gonna make this just a little bit color. Okay, so what you see here is that you see that there's a little curve here, and then we want to make it a little more visible. So make it 8. And okay, some of you may get this, some of you may not, but everybody will get something out of this. Okay, so this is provided that you're using your graphing calculator. You're still identifying the positive, whatever number make it positive or 0, right? So let me see if this will make it better. So you see here, the graph is just a little bit awkward. So let me make it 10. because I want this to be more visible. So maybe I put 6. That's too bad. No, this is still 5. I'm gonna make it 6 here. Right? Wait, this is so awful. Okay, suppose this is a decent picture. You see there's a crossing here and there's no crossing here, and these two pieces of curve, then you might have learned, or you might not have learned that, then you see there's a disconnection. There's a disconnection. So what happens is, I want you to see the whole picture. So if I put, I want you to focus on the broken piece, right? So you can zoom your graph, right? So you see something like this, and then you see what is separating them. What is the line that's separating them? That line that's separating them actually has something to do with the domain. And that line is x equals to -1. Okay, so I'm going to graph this line for you. Okay, so there's a line of, it's a forbidden line. Why is it forbidden? Because it's not in the domain. That input -1 is not in the domain. Okay, that's what separates this big curve into two pieces. But you can see, using the same principles we have learned before, right? You can see that this piece of curve is positive, and we want positive, right? And these pieces of curve, that's negative. But there's a little piece that's above it. So there's a positive piece over here. And then you want to know, where does it cross? Where does it cross? Well, then you realize, oh, when x equals to 3, it crosses. Do you guys follow me? That's the 3. So if you know how to read this chart, you can still give the solution. And if you have a graphing calculator, right? And you still be able to identify the solution as x less than -1, or x is larger than or equal to 3. Do you follow me? So this is the graphing method. But we didn't talk about the graphing of how to do graphing by hand. So there's a lot of details that's missing, which is not in our current lectures plan, which is not in the plan of our current lecture. But you can see the same idea still applies, isn't it? Do you follow me? The same idea still applies. Does everybody follow me? Right, so if you can get a decent graph, you can identify those points of interest and what it changes sign, okay, you can still figure this out. And here you have to make this piece a little bit better. Okay, so that's a graphical method, or in comparison with the quadratic ideas, right? The above x, above 0, or below 0. Okay, so we're talking about these ideas. Okay. And the case method, I'm not going to talk about it right now. So let's look at number 9. Number 9 and number 12. Are you ready? Number 9 and number 12. Let's do number 9 first. Okay, number 9, I want everybody to be involved. Do you want to take a break? Do you want to take a break? So let's take a break. Okay, let's take a break. Take a break and come back at 11. Come back at 11:41. Okay, come back at 11:41. Break. Back at 11:41 a.m. Okay, so let's take a break. I'll see you guys soon. Okay, guys, welcome back. Please come back. Okay, so we pointed out some of the pitfalls in solving these inequalities, and we also we reconnect with the ideas we've done before. Okay, I made some adjustment to the picture, so this time it sees a little bit better. And the idea is the same. It's really we want that function to be greater than or equals to 0, right? So with a picture like that, it's easier to identify which one, which piece above x-axis, which piece is below, so we can identify all the solutions. Just remember, we want to find all the solutions. Okay, so the pitfalls, we talk about that this method is terribly wrong, and the step is here, and the logic behind it, right? The logic behind it. And so mathematics, you can see they're all from very basic observation, very basic observation. You don't need to know rocket science to understand math, right? To understand some basic algebra, you don't need rocket science. So with that said and done, right? Let's look at number 9. Let's look at number 9. Okay, so now I'm gonna, and at this time I see this inequality, right? So I'm gonna ask you a question. A student did the following steps. Please check his work. Okay, well, we just talk about all the things we talk about, right? I want you to check the work of a student. A student did the following steps. So could you please go through the steps and tell us what's wrong and what's right? What's wrong and what's right? Step 1, 2, 3, 4. If this is true, of course, this is an if statement again. This is still an if statement. Okay, don't forget. Read it as an if statement. Okay, if the quotient is greater than equals to 1, okay, and we want to identify all possible values for x, solve for x. So the student multiply both sides by 3 minus x. I want to hear your comments. You can put it on the on the chat. Okay, which step is right, which step is wrong? Why is right, why it is wrong? I just like to beautify these a little bit. Okay, comments. Brianna, what do you think? Francisco, are you there? Marcelo, Safactra, Ellen? Please comments. Ellen, what do you think? Anybody want to say something? Hello? Let's see what's on chat. No comments on chat. Are you guys there? Are you there? How did I get 2x? Well, we add x on both sides, subtract 3 on both sides. These are the steps that you guys are more accustomed to, right? Write it down. Write it down on your paper. How would you have done this? And on this step, divide both sides by 2. Alan, what do you think? Brianna, Marcelo, Step 1 is wrong. Very good. Very good. Why? Why? Excellent. Why is wrong? Why is wrong? Very good, Alan. What's wrong? Why is wrong? Why is wrong? What is the reason it is wrong? Everybody, come on. Francisco, why step 1 is wrong? Brianna, why step one is wrong? Alan is right. He pointed out step 1 is wrong. Actually, it's from step 1 to step 2 is wrong. Right? The step 2 is a consequence of step 1. And you can say step 1 is wrong. Yes, that's fine. What is wrong? Comments? Look at your notes. What is wrong? We don't know the sign of 3 minus x, isn't it? Is that right? The sign of what is unknown? Yeah. The sign of 3 minus x unknown. Right, sure, we can require 3 minus x. We can request the denominator cannot be 0, so x cannot be 3. But 3 minus x may be positive or it may be negative, right? If it's positive, then this will be right. If it's negative, this has to be switched. So do we switch or do we not switch? So the same dilemma, right? It's the same dilemma. So for that reason, I want you guys to write it down, all of these, and cross it out. Write down the reason, because this is one of those very, very common mistake. Common and popular mistake. Okay, for which you're going to get 0. Okay, for which you're going to get 0. It's very easy to do. Because it's easy. Not all the easy method is correct. Some are correct, okay, but not all of them. And what are the devils are in the detail? The devils are in the detail. Okay, so don't do it. This is very tempting to do. This is very tempting to do. Okay, it's very tempting to do. So please write it down. I'm gonna go on, okay? Get your paper, pencil ready. Let's do it together. I know you might be tired, right? It's probably lunchtime for your family. And let's just, just keep going for another hour. Okay, and this the next steps, then you say, can we do pictures? Of course we can do pictures, right? Of course we can do pictures. But we're gonna be consistent with the common methods. Okay, there's so many different methods you can do. Okay, even with pictures, there's different ways to do it as well. But I want to be consistent with the commonly taught methods. Okay, and the commonly taught methods does not include all the methods, but it has to agree with the mathematical principle. It has to agree with the mathematical principle. Okay, all right, did you guys write it down? So when you are taking notes, you're not only taking all the right ways to do it, you also need to take down the wrong ways, especially those popular common mistakes. You write it down. When you review, you remind yourself that, what, this is wrong and this is why it's wrong. So don't do it. Do you follow me? Don't do it. Okay, are you ready? Did you write it down? Did you write it down? Okay. I assume you've written it down because I'm going to clean it up. I'm going to clean this up. Okay, so that step is wrong. Okay, cleaning up. So how should we do it? How should we do it? The common way to do it is to make it to something like, what do we do? Like number 7 and number 8. Okay, because if you look at what's in number 7, number 8, one side is 0. Sometimes it's greater than 0. Sometimes it's greater than equal to 0. Sometimes it's, less than 0. So we're going to make 0. There's no 0 here, so we're going to make 0. How do we make 0? We subtract 1 on both sides. Okay, so we're going to subtract 1 on both sides. Greater than equals to 0. Okay, so if this is true, then this is true. Okay, so we can subtract the same number on both sides. We don't have to do any switching. Okay, we don't have to do any switching. If we add or subtract, right? So let me put a summary here. Okay, when we multiply, these are the compensating to principle number 4. Okay, complementary, compensate principle number 4. Okay, these are compensating principle number 4. Principle number 4 says, if A is the same as B, then A times C is the same as B times C, provided C is not 0, right? When we come to inequality, then we have these two true statements. Okay, so these are compensating principle number 4. Okay, but this didn't mention adding, subtracting. What if it's adding, subtracting, right? So if if A is larger than B, then you do A plus or minus C is still going to be greater than B is greater than a plus or minus C. Okay, so let's just do plus. Okay, minus is the same thing. Subtracting is still true. Got it? If it's less than, it's still less than, right? So this is still true. This is still, so when you're adding or subtracting, there's no switch. Only when we multiply or divide, we have to switch according to the numbers we multiply or divide. If we multiply or divide by negative number, we have to switch. If we multiply by or divide by a positive number, we do not switch. But when we are adding or subtracting, we never have to switch regardless. Do you guys follow me? No CC, no switch, no switch. Okay, no switch, no switch. Switch is needed. Do you guys follow me? Did you write it down? Okay, so when we subtract by 1 on both sides, no switch. And this step, we call it make 0. Right? For number 7, number 8, there was 0 there. So we don't need to make 0 in particular. But when there's no 0, we need to make 0. Do you follow me? You will find that making 0 is a very, very common technique. Why? Because it's easier. Okay, larger than 0 is above. Below, less than 0 is lower than x-axis, right? It's the same idea. It's the same idea. Okay, so we make 0. Okay, and then what we do? We're going to find common denominator. Okay, there's only one denominator by this time. Okay, this will require some algebraic proficiency. 1 is 3 minus x over 3 minus x. So we are making common denominator. Okay, so make common denominator. You follow me? Making common denominator. After we made the common denominator, now we have the same denominator, which is 3 minus x. And we're going to take this numerator subtracting the other numerator. So we're going to have 3 plus x subtracting 3 minus x. So here, I want you to be very careful. Don't write it this way. You're making a mistake right there. You need to know that you need to have parentheses for it. Okay, because you're subtracting the entirety of the numerator. So you need to put a parentheses here. The difference it will make, okay, let's look at the next correct steps, okay? And I will point out the common mistakes here, okay? Because this question, I have used this question to test our students' algebraic skill many, many times over. So when we open up the parentheses, we distribute the negative sign to 3, and we distribute the negative sign to negative x. So it turns into negative 3 plus x. If you forgot the parentheses, and you're going to get disaster, okay? You're going to get disaster, okay? So you need a parentheses here. Do you have to show this step? You don't have to show this step. This step is optional, but you need to know. You need to know. Do you guys follow me? Does everybody follow me? Do you guys follow me? These steps are optional. Steps are optional. And the next step we're going to combine the like terms. We keep the same denominator. We combine the like terms. You can see 3 minus 3, that makes 0. You're going to have a 2x on top. And you're going to have greater than or equal to 0. Okay. To further simplify this, I'm going to divide both sides by 2 or multiply both sides by half. Okay, so I'm going to multiply both sides by half. You don't have to do this, but this, I will assure you, this will make your life just a little bit easier. So as enhancement to your algebraic skill, you're going to end up with x over 3 minus x greater than or equal to 0. Does everybody follow me? Okay, so now, did you write it down everything? We're not done yet. Okay, we're doing the first part. We were just doing the first part. We're not done yet, but these steps is critical to, it's critical for you to see if you have those basic algebraic skill. So what I'm going to do is I'm going to give you 5 minutes. I'm going to put these, I'm going to stop sharing screen. I'm going to give you 5 minutes. I want you to reproduce these steps. Are you ready? Okay. Right now it's 12:07. Okay. Reproduce these steps. I'm going to stop share. Okay. So I'm going to come back at 12:12. So please reproduce those steps. Okay. This is the moment you're going to re-examine how strong you are algebraically. No fear. Okay. I'm not coming to your house to check on you. I'm not coming to your house to check on you. Okay. This is the moment you want to see if you can redo the steps. If you cannot, it's okay, no big deal, right? You can do it again. You're gonna see. I will bring the steps back to see where you got stuck. I'm just gonna grab a little bit of water. I'll be right back. Take your time, okay? Self-assessment, you're assessing if you get it, if you understand the steps. You have to be able to do it by yourself. But these are one of those things, no one can do it for you. Okay? But if you don't know how to, you cannot do it with yourself the first time, no big deal. You keep on practicing. You keep on practicing. That's how we get better. Okay? Take your time. Take your time. No pressure whatsoever. I'm not assessing you. Okay, you just want to make sure you know how to do these. Okay, because the examples we went over today's class, it will be showing up on your quiz. It will show up on your quiz. All right. We ready? We see there's no big deal, right? You try it, it works. If you don't get it, you can look at the notes, and now you can look at the whole process, right? The first step is making zero. Making zero is easy, right? We have these principles we can use. So this principle, actually, you see this principle, right? It's the same as, it's similar to principle number 3. Okay, so let me just put them together so you can see the comparison, right? So you don't get all confused. Oh, I have so much to remember. No, you don't. There's not much to remember, right? So A plus C is equals to B plus C. So you can see that these two principles, when you're adding, subtracting, whether it's an inequality or equation, it doesn't really matter. It doesn't make any difference. Only when you multiply by a negative number on an inequality, there's a switching takes place. Okay, there's no switching. See, no switching here, no switching here, right? Only when you multiply by negative or divide by negative, right? Okay, so let's go back to the steps one more time. We make 0 because we want to make it like a 7 or 8, right? We make something similar to 7 to 8. And we make a common denominator, right? And then we make sure the numerator subtract the numerator here, subtracting the other numerator, but we're subtracting the whole of the other numerator. And when we open the parentheses, we have those parentheses inserted. If you're missing these parentheses, so if you have something like this, I will identify that as a mistake, and everything else you do will be 0, will be null, okay? So be sure you have these parentheses, whether you show this step explicitly or not, because your next step will reflect whether you have that parentheses, okay? So I can assess it that way. So you have these correct steps. If I were you, I will do everything in details. So when I go back to check, I can find out what have I done wrong, or what have I done right. Got it? So now we have 2x here, and we want to simplify this more. This step is entirely optional, but it's really a desirable step to take because you make your final expression much easier. So I want you to compare this expression with, compare with number 7 and number 8. Okay, compare with number 7 and 8. What do they all have in common? One side is whatever is a quotient and the other side is 0, right? So that's the whole point of making 0. So we make it a singular fraction form. We make it a singular fraction form. Got it? And then what do we do next? We do the sign. We do the sign. Okay, so we're going to do the sign of numerator, right? Sign of x. Sign of x is easy, right? The sign of x is easy. Okay, where does x change sign? At 0, right? At 0. When x is positive, right? When x is positive, it's positive. When x is negative, it's negative. So the sign is negative when x is less than 0. When x is 0, x is 0, right? You can see that's very straightforward. And when x is positive, x is larger than 0, x is positive. So this is the easiest part, right? Now, look at the sign of 3 minus x. 3 minus x. Okay, and we have this number line still. Where does 3 minus x change sign? At 3. Right, at 3. Right, and what is the sign? What is the sign? At 0, at 3, of course, is 0. But when x is less than 3, when you plug in number of x less than 3, say you pick up 0, right? 0 is less than 3. What you get? These signs are actually positive. Okay, this example also want to show you that you don't always have a negative, positive, negative on the left. It depends on what you have. Okay, do you follow me? So at 3, 3 minus x is a 0. After 3, 3 minus x is a negative. Right? All you have to do is just plug in a number from, you pick a number from here, you plug in, say, suppose you pick a -1. -1 is 3 minus -1 is 3 plus 1. That's a positive number. So all of these are going to be positive. And 3 minus x changes sign at 3. If you plug in a number greater than 3, and 3, say, -4, 3 minus 4 is negative. So here, all of these are going to be negative. Do you guys follow me? So next, we're going to look at the quotient, which is x of the sign of x over 3 minus x. Okay, so number line, we got a 0. And then continue on the number line, and there's a 3. Right? And continue that number line. So that's a 0, and that's a 3. So let's look at the sign changes. Okay, so we really just go point by point, number by number, every number examined. Right? And we use principle number 6. We use principle number 6. So now let's see what we get. Okay, when we pick a number from less than 0, any number, and you plug in this expression, and you're going to be doing a negative divided by positive. Negative divided by positive, what we get? We get negative. Right? We get negative. Does everybody follow me? So you get a negative. At 0, when x is 0, we get a numerator is 0. Denominator is 3 minus 0. So denominator is not 0. So numerator is 0 at 0. Therefore, that quotient is going to be 0. If we pick a number between 0 and 3, we plug in, we have a positive divide by positive. Positive divide by positive, that's going to be positive. At 3, what happens? If x is 3, we have 0 as a denominator. When 0 is a denominator, it's undefined. So we put a, infinity in place. If we pick a number larger than 3, we're doing a positive divide by negative. So that's going to be a negative. You follow me? And we want the quotient to be what? 0 or larger, positive or 0, positive or 0. So where do we find those input such that the output is positive or 0? So they're all here. Does it include 3? No, it doesn't. Does it include 0? Yes, it includes 0. So the solution. What will be the solution? The solution will include a 0, x is greater than or equal to 0, and less than 3. Does everybody follow me? So the latter piece over here, you see it's a similar, right? It's a similar to what we did for number 7 and 8. The only additional step is what? Is the making 0 part and the finding common denominator part. Do you follow me? So the only additional step is the making 0 part and the making common denominator part, right? Those are the basic skills that we might have, we might not have, Okay, this is intermediate algebra class, right? So if you don't, have it, there's some practices you can find from beginning algebra, but I will try to make time for, in-class practice as much as I can. Okay, are we good? All right. Now, do you want to try the whole question all over again? I think I will leave it for you after class. Okay, you'll be quizzed on these things. So you have to do it. Okay. All right. So without further ado, all things combined. Okay. Did you write everything? Did you write down everything, please? Did you guys write down everything? Last but not least. Okay. Let's look at number 12. I'm not going to do the graphing method, even though I mentioned this for, number 7, because the graphing method is, I assume that not everybody has the graphing tools, and I just want to relate to the ideas. Okay. So next, I want you to try number 12. Okay, we're going to do this together. Number 12, we're going to do number 12 together. Okay, so with all that said and done, 12. So now we have all the tools, right? So we understand we have 2x divided by x plus 3, and we want that to be less than or equals to 1. We understand this is an if statement. If a quotient less than or equals to 1, right? Okay, and we're going to identify or find all possible values for x. So all the solutions, okay? And where that denominator cannot be 0, so that's considered a given. Okay, so what do we do? You're not going to multiply both sides by x plus 3, right? Of course not. We don't know the sign of x plus 3. But what we can do is that we can make 0. -1 less than or equals to 0. Are you guys following me? So write it down on your paper, please. And then the common denominator step. 2x over x plus 3. And the common denominator, right? When we subtracting the same number on both sides, we don't have to do any switching. So x plus 3 over x plus 3. All right. And then what do we do? Now we have the same denominator. Okay, I'm going to wait for you guys to give me the answer. So there's still no switching. Right? Basically, you read it at, if this is true, then this. If this is true, then this. And if this is true, then this. Right? It just if then, if then, if then, if then. That's how you read it. Right? That's how we read it. If statements. There are only 2 kinds of statement in mathematics. One is statement and the other one is if statement. That's all. That's all we have. So what you get here? So in the end, we get 2x minus x, that's x, So we get x minus 3 over x plus 3, and that's less than or equal to 0. Are we ending up at the same place? Everybody? Yeah? I'd like to line them up. Are you guys with me? Yeah? Sorry. I just like to line them up, line those inequalities when I have time. Are you with me, everybody? Okay. And then we do the sign. Okay, the sign of x plus 3. How does x plus 3 change sign? It changes sign at where? -3, right? And when x is less than -3, say -4, you plug in, you're gonna get negative. So negative, negative, at -3 is 0, larger than -3 is gonna be positive. Right, and then you're gonna work with sign of x minus 3. Now what do we get? +3, that's where it changes sign. And the sign is when x is less than 3, x minus 3 is negative. Otherwise, it's going to be positive. So these are positive signs. So it's not that terribly difficult, isn't it? Is it terribly difficult? And last but not least, the sign of the quotient. Okay, so be reminded that we want to guarantee this quotient is less than or equal to 0. So I have two places where a sign change could take place. One is a -3, right? And the other place is a +3, positive sign, right? Now, at -3, you will draw a line, right? There's a -3, that's a line, you know, that's a divide. And there's another divide. Oh, that's misplaced. Sorry about that. Here, that's better. And then you just compare the sign. Okay, if you pick an x over here, a number less than -3, you plug in, you will encounter a negative divide by negative, right? A negative divide by negative. So you're going to get positive. Yeah, you're going to get positive. When at -3, what happened at -3? What happened at -3? That's when x equals to -3, the denominator is going to be 0. The numerator is not 0, it's -6. Therefore, this is undefined. 0 denominator is not allowed, undefined. So when we pick a number between -3 and 3, say I pick 0, then it's going to be a negative divide by positive. So the negative divide by positive is a negative according to our principle number 6. At 3, what happened at 3? At 3, the numerator is 3 minus 3, that's a 0. And denominator is 3 plus 3, that's a 6. 0 divided by 6 is 0. And when x is larger than 3, we're doing a positive divided by positive. So that's going to be positive. Got it? in the end, do we have a solution now? Do we have a solution or not? On this form, we want this quotient to be less than 0 or equal to 0. So where is it less than 0? So you just identify those negative, right? Those are the negatives. And these x's will be the solution, including the one that make it equal to 0. So this guy is a solution as well. So the final solution is what? What is it? Is larger than -3, but less than or equal to +3. +3 must be included. So that's the final solution. Does everybody follow? Has it become easier? Okay. Okay. I hope that helps, right? And we work with the quadratic and then the quotient form of inequalities. And I think today we can wrap this up for alpha 32A. Alpha 32A. If you want more practice, you can do alpha 32B, even though I'm not assigning those as your homework. For those of you who really want to enhance your algebraic skills, then these are really, really good exercise for you. The more you practice, the better you're gonna be. Okay. So I think it's a time to wrap up and move forward. Okay, it's wrap up and move forward. Okay, so these are the residuals we left from before spring break, and I hope that's a good review and a good closure. You should expect a quiz either today or available tomorrow, either available today or available tomorrow. That's going to be address these stuff we are doing in class. Okay, we're doing in class. And next, we're going to move forward to alpha 33. I believe that these material might be relatively easy for you. Okay, you might have these before, but I just want to give you a at least a review on these. So let's move forward and move on to alpha 33. Alpha 33. Okay, the lectures is recorded, so if you have any, if you need to watch the recording again, so feel free to do that. In fact, I encourage you to watch the lecture again. That's why I'm giving you questions on quiz that's related to the lecture. Okay, that's related to the lecture. My lecture, I think, are loaded with a lot of information. Most people, I think, need to watch it again. Okay, but anyway, alpha 33, we have a simple question. What is the difference between a to the power 5 and the 5a, 5 times a? Do you know the difference? And of course, after we pointed out these differences, we're going to go straight to 34a. You know? Do we know? Do we know the difference? Yes or no? No? Okay, not sure, right? Okay, 5A, meaning, do I see any comments on chat? Okay, 5A is A plus A plus A plus A plus A 5 times. Okay, A to the power 5, however, is A times A times A times A 5 times. That's a difference. Okay, so that's the difference. So now we're going to review that part called exponential. Okay, exponents. For exponents, there are a lot of rules, but I don't want you guys to be, so frustrated by the memorization of these rules. In fact, you never need to memorize it. All you have to do, you understand this principle, you understand this definition, okay? Because it's all started with like 2 to the power 5. Let's say, let me change the number, 2 to the power 3, right? 2 to the power 3 means what? It means 2 times 2 times 2, 3 times, right? So that's going to be 8, right? And you use this principle, you use this definition, and of course we call 2 is the base and 3 is the exponent, right? And you just expand it. A to the power 3 is A times A times A times A, right? B to the power of 7, right? What would that be? That's going to B times B times B times B times B. How many times? Did I go over? 1, 2, 3, 4, 5, 6, 7, 8. And I think I went over 1, 2, 3, 4, 5, 6, 7. 7 times. Right? So these are the basic definition. From this basic definition, we derive those rules. And I was just teaching pre-calculus before this class. Okay, I was just shocked that some of our students who are taking pre-calculus, they don't know some of the basic rules. For example, I was asking them, this is the exact question I was asking them, b to the power m multiply b to the power n, what does that equal to? And some of them tell me it's b to the power of m times n. I was basically appalled. Okay, so don't try to go through your memory, say, oh, do I remember this or I don't remember this? It could be this, it could be that. No, use your reason. Use our reason from the basics. From the very basics of this meaning. Okay? So when I saw this mistake in a pre-calculus class, that's pretty scary. That's pretty scary. Okay? But you also need to understand, you don't need to memorize, you need to understand. So do you have your paper pencil with you? Do you have your mind with you as well? With me? I totally understand. We can be somewhere and our mind is 10 miles away. Yeah? Okay? So this is a terrible mistake, and I totally didn't expect it from a pre-calculus class. Okay, so this is a terrible mistake. Okay, so let me write it down. I don't want you to remember this mistake, and I want you to see why it is a mistake. Pre-calculus class. think those students really should be with you guys. Okay, those students should really be with you guys in taking intermediate algebra. But anyway. All right. So look at alpha 34A. Okay, the first, I would say the second row. Okay, so I'm going to make a similar table. Okay, so hopefully this will help. Okay, I'm going to make a similar table. Okay, and I have ABC, so hopefully then you guys will work with me. Please work with me. Okay, please work with me. ABC. And I didn't have more than that. Okay, so just the 4 columns. The first column is about a raised to the power of n multiply a raised to the power of k. It doesn't matter how you call these. Sometimes the text will use m, n, so on and so forth. Okay. You see here, I didn't give you the formula. Okay, I want you to figure out the formula. So how do you figure out the formula? And on here, I have a to the power 5 multiply a raised to the power 3. Okay. By the basic definition, right? A to the power 3 is a times a times a 3 times. A to the power 5, of course, is going to be what? So a to the power 5 is really a times a times a times a times a, right? That's a to the power 5. A to the power 3 is a times a times a 3 times, right? And when you put them together, how many a in multiplication? So you're going to have a raised to the power of, you just have to count the number of a's. 1, 2, 3, 4, 5, 6, 7, 8. 8. How else can we get 8? 5 plus 3. 5 plus 3. Does that make sense? And that is how you figure out the formula, which is a to the power of 5 plus 3. So now you know why this is a terrible mistake, right? Right? Now you know why this is a terrible mistake. So can we guess if this will be a raised to the power of what? M plus k? Do you follow me? You see, you don't have to memorize. Do you follow me? We don't need to memorize. We don't need to memorize. You can just set up a similar scenario and figure out there for yourself. Okay? Are you guys with me? Because okay, so I want you guys to put it on your paper pencil. Okay? A to the power of n, what does that equal to? A to the power n means a times a times a. How many times? How many times? N times, right? Is that n times? N times. Yeah? And a times k, and I'm sorry, a to the power of k, how many times? How many times? K times, right? Yeah? K times. So this is a k times. So n times plus k times is how many times a is being multiplied, yeah? So in the end, what do we get? So you can totally figure out this formula, don't you? I believe in you. I do. Okay, so that's the column A. Column A. That's a column A. We're not doing column B or C yet. Okay, we're not doing column A, B, or C yet. So let's first figure out the basic formula. Now, a to the power of n divided by a to the power of k. How should that formula be? Okay, how should that formula be? We have an example. Okay, some of you may know this formula, some of you may not know this formula, but that's okay. Let's go to the basics. Let's go to the basics. Okay, I'm gonna make the fonts large enough. So the top is what? Is a times a, how many times? 5, 6, 7, 8. The bottom, how many times? 5 times, right? Yes? And what you do? You reduce, right? There are 8 times, there are 5 times. So what do we get in the end? We have a to the power of what? 3. A to the power of 3, how else you can get 3? 8 minus 5, right? So A is 8 is in the place of n, 5 is in the place of k. So this formula should be what? A raised to the power of what? N minus k. Do you follow me? Does everybody follow? Yeah, so now we're just doing column A. We're just doing column A. We're just doing column A. Okay, we're doing column A. Now, what if we do a to the power of k, a to the power of n? You know, just take your time to do these things. Okay, so you're gonna have a to the power n, that n times, right? That n times, right? N times, right? And here you have a to the power of k, k times, right? K times. K times, they're in dividing. And of course, we can we can remove the parentheses, we really can. Right, so n times, k times, it, you know, a lot of these are reduced. So you're gonna get a raised to the power of what? N minus k. So the formula, you can derive the formula yourself, can you? So far, so good? So far, so good? So let's look at this next one. Okay. The third row, the fourth row, which is b to the power of n, and then raised to the power of k. We have layers of exponents. And so the examples we have here on column A is b raised to the power of 5, and then inside the parentheses. So we have layers. Okay. So suppose this is omega. Okay, suppose that is omega. And what is omega to the power 3? That's just really omega times omega and times omega one more time, right? And now that omega is what? Is b to the power 5, b to the power 5, b to the power 5, b to the power 5. Do you guys follow me? And now this will fall into which type? Right here, right? So we're gonna get a b raised to the power of what? 5 plus 5 plus 5, yeah? And that's a b raised to the power of what? 3 times 5, right? Or 5 times 3, same thing. Yes? 5 times 3. Or 3 times 5. No difference whatsoever. Do you follow me? So what will be the formula here? B raised to the power of what? N times K. N times K. So these first column is intended for us to understand. So if you put this in a more general form, right? In a more general form, right? So what does that mean? Right? This means this is once again, this is omega, right? This is our omega. Omega to the power k is really just omega multiply omega multiply many omega. Okay, sorry, I'm not playing music here. I pressed the wrong button somewhere. Never mind. Okay. So you can see omega k. So now if omega is b to the power n, so this is going to be b to the power n, b to the power n. Do you follow me? Okay. How many are these? K, right? That's a k. K times. K times. Okay. And what would that be? We're going to be doing b to the power of what? N plus n plus many n's, right? How many times? K times again, right? Still K times, yeah? So the sum here is how many times? I hope I gave you a good picture, right? For your future reference. And K times, right? Remember we talked about the difference between a to the power 5 to 5a, right? So this will be equals to b raised to the power of what? N times k. Got it? Yes? Is everybody with me? Okay, we have 4 minutes. Let's do 2 more. Two more. Okay. So these will be relatively easier, I believe. Okay. These will be relatively easier. Did someone comment on chat? No. Okay. No comment. Okay. So the next one is A times B inside the base is a product. And we have the power n. Okay, so these will be relatively easy. For example, if you have AB to the power 3, what does that mean? That means A times B 3 times. 1, 2, 3. right? And you can put all the A's together. And you can take all the B's together. So in the end, you have A to the power of 3 multiply B to the raised to the power of 3, right? So A times B to the power of n is equals to A to the power of n multiply B raised to the power of n. And the same will be true for division. To the power of n. Okay. And we have a division, which is, you know, this example we have here, right, is A over B to the power of 4. And what would that be? Well, A divided by B 4 times. 1, 2, 3, 4. So we're gonna multiply all the A together, multiply all the B together, so you get A to the power 4 divided by B raised to the power 4. So these are the basics, and we shall continue on Wednesday, but let's wrap this up. Okay, so A to the power of n divided by B raised to the power of n. Boom. Okay. And you can work on the proofs like what we did earlier, right? It's like this one, like A times B to the power of n, that's going to be A times B, right? How many times? 1, 2, n times. N times. Okay. And that's, you're gonna mention this is n times. N times. Okay, I'm sorry, I'm holding you up almost. I just want to complete this part, right? And then you're gonna have all the A's together, right? A times A together. Right? How many times? N times, yay. And you have all the B's together. B times B times B, sorry, B. Well, come back in, okay? So there's another n times. There's another n times. Right, so n times here. And I think you guys got it, don't you? Did you get it? Do you see the picture? The best will be you do it yourself, really. The best will be you do it yourself, okay? So in the end, when you do this by your own hands, you wouldn't be making those mistakes. You know, some people, they don't want to do the basics. And then they, I don't know, they just, and for A divided by B, I'm going to leave that for you. Okay, so please try dividing A over B. Just go through that process. Just go through that process, right? And you're going to go through the similar steps and you realize, yeah, that's true. And you also have the examples. And when we come back on Wednesday, we will continue on this table. But this table will be your homework. Will be your homework. And do as many as you want and as many as you can. Okay, in this section. Okay, so I will see you guys on Wednesday, and you will have homework, and I will give you a quiz today. Okay, have a great day.